Assalamualaikum warahmatullahi wabarakatuh and good morning everyone. So today we will continue our lesson on the last chapter for the subject Introductions to Scientific Programming. So this chapter 14 is all about object-oriented programming. So let's start. So the first part of the lesson today is what is OOP, object-oriented programming? So before we proceed with the definitions of the object-oriented programming, let's take a look at the definition of procedural programming. So procedural programming is a list of instructions to perform a task. So for procedural programming, it is only a list of instructions. Okay, so this has no association between the functions or the data they operate on. Okay, so for procedural types of programming, they doesn't have any functions or they doesn't have any data. So what they have is just a list of instructions. Okay, so the example for programming language that is using procedural programming is Fortran and also C. Alright, so what is object-oriented programming? So object-oriented programming is a programming paradigm organized around objects with data and associate functions. So the main difference between object-oriented programming and procedural programming is object-oriented programming, OOP, is a programming which associated with some functions and some data. Okay, so in OOP, data indicates states, function indicates the behavior. And the example for the programming languages that is using OOP is C++, Java, and also C#. Alright, why we use OOP? What is the advantage for OOP? So OOP will create a coding environment which has a modularity. So modularity is it is easy for us to change or to modify because of the structure and architecture of OOP. Next is abstractions. So in OOP, it is easy for us to understand what is coding does. Okay, what is the function of this coding? So this is abstraction. Alright, so next is reuse. So because OOP is easy to understand, so it is easy for you to reuse the coding. So next is code maintenance and maintainability. So in order for you to to change or to modify or to troubleshoot the code, you must first understand the codes. So because OOP is easy to understand, so the code maintenance and maintainability is easy. So next is code expansion and extensibility. And also OOP also improve the code understanding. So for people who doesn't have that much advantage or that much skills in programming, they can understand the coding better by using OOP. And data encapsulations, and lastly is logic encapsulation. So it is easier for us to do data and logic encapsulation by using OOP. Alright, so next let's take a look at some of the OOP fundamentals. So the first fundamental that we will take a look is class. So what is class? So class is a template for creating objects, defining properties and methods, as well as default values or behavior. So in OOP, class is actually a template for you to create an object. Okay, so later on I will show you some of the example of the class and how you want to create an object from the class itself. Okay, so inside the class they have properties and methods. Okay, and also in class it also has default values or behavior. Alright, so next is an object. So what is an object? So object is an instance of a class that have a state, properties, and also behavior. So object is like the way that we wanted to call a class. So when we creating a class and we wanted to use a class, we need to create an object. Alright, so next is properties. So properties is actually the data associated with an object. So basically in OOP, properties is actually the variables inside the class. Next is methods. So methods is basically a function inside the class. So the class is actually like an idea to solve a problem. So in order for you to solve the problem, you need the variables or the data, which is we call it in OOP properties. Okay, so and then what you will do with data? So you need some functions. So for OOP, the function is called methods. Okay. Alright, next you have attributes. To attribute, it is used to modify behavior of class and class components. And lastly, and inheritance. Okay, inheritance, it is object or class which derive from another object or class. So if you have object or if you have a class, inheritance is a class or an object that you get from another object or another class. Okay, so last fundamentals for OOP that we will learn today is polymorphism. So polymorphism is actually a single interface to entities of different types. Okay. All right. Okay, so OOP in MATLAB. So in MATLAB, OOP has been supported starts from MATLAB 2008B and above. So it means that if you have the versions of 2008A and below, it will not support the OOP. Okay. Next is dot notation works in R2014B and later. So in OOP, we are using dot notation to get the data, to set the data, and also to access the functions. Okay. So later on, I will show you some of the example of dot notation. Okay. So if you have a MATLAB R2014B and below, it will not support the dot notation, but I'm sure that you already have R2020, right? Because UTM provided those software for you. Alright, next is MATLAB R2015A has introduced additional functionalities in terms of editing capabilities. Okay, so for those who use MATLAB 2015A, you will have another additional functionalities. Alright, so it is better for you to have the most recent MATLAB. Alright, next we will take a look what is a class and what is object. Okay, so a class is a template for ideas or items. So it is composed of a definition of a data structure and methods that can operate on a data structure if created. So basically a class is like a template for your idea or for your solutions. Okay, so in class it has like what do we call this thing, the data and also the methods. Okay, the data is the variables, the method is the functions. All right, so an object is an actual instance of a class. So an object is actually the way that you wanted to call a class, you need to initialize an object. Okay, so to use a class, one only needs to know the interface of the class. For example, the methods of the class. So if you wanted to use a class, you need to know what is the function of the class itself, because if you don't know what is the function of the class, you will not know how to call the class and what is the name of the class itself. Alright, so this is OOT, object-oriented terminology. So this is the representation of class and object. Okay, so class is actually an outline of an idea which contains properties, that is data, and also methods, which is the algorithm or functions. Okay, so object is like a specific example of a class and also the instance. We wanted to call a class, we need to define an object. Alright, okay, so let's take a look at MATLAB OOP. So in MATLAB, there are some of the syntax that you need to know in order for you to use OOP. Okay, first is you need to learn about class, you need to learn about property, you need to learn about constructor, methods, static methods, constant property, private property, handle versus value class. So all of these MATLAB OOP functions you will learn in this chapter. So apart from that, MATLAB OOP also have events, overloading, inheritance, and also abstract class. But we will not cover this topic in our class. Alright? Okay. Now, let's define a class. Okay? Because OOP is all about the class and object, right? So let's define a class. So a class is instantiated with the class def keywords. Okay? So in order for you to define a class, you need to use the syntax class def. Okay, so the source code must go inside a file with the same name. Okay, for example, This example shows you the example of initiating a class with myRectangle. So the name of the class is myRectangle. So you must save this file into myRectangle.m. Alright? And then this is the class. Okay? You see that in class it is a template for ideas. Okay? So inside the class it has properties and also it has methods. Okay? So in properties, you must put your variables inside the properties. Okay? Properties, you must put properties syntax first, and below that you put your variable, and then you must end your properties with syntax end. Okay? So similar with methods. Okay? So you must start your methods with the syntax methods, and then below this methods line you need to put your function. Okay? Your functions or your command or something executable. Okay? And then you must put end after the methods. Alright? And after that, you need to end your class. Okay, so this is how you can initiate a class. Alright? Okay, next is defining a property. Okay, how to define a property, which is the variable. So the internal state of the class is saved as properties of the class. Okay? And then no need of defining the type of each property. So in OOP, you don't have to define the type of your variable. Okay? So you can access the property or methods by using the dot operator. So this is the dot operator that has been mentioned in the previous slide. Okay? So this is the example for the class myRectangle with the properties of the variable of width and height. So you can see here that we didn't initialize any types of variables. Okay? Integer, double, character, we doesn't initiate any what we call a variable type. Okay, so in this example, the object myRectangle is defined with two properties, its height and width. All right, so create an object R of class rectangle as follows. Okay, so access the property using the dot operator. So this is how the dot operator is being used. Okay, so first you are creating an object called R, which call the myRectangle class. Okay, and then your object R will define as myRectangle with properties. So your object R will become myRectangle. So inside your object you have the data width and data height. Okay, so if you wanted to set the data inside the class myRectangle, you can use dot operator, where you can start with your object name, which is R, dot, and what is the properties or the variables. Okay, R dot width equals to 5. So this is how you can set the width to equals to 5. Okay, so width is the properties inside your class. Okay, all right, so right now when you run this command, you already initiate an object R with the properties of width equals to 5. Okay, so similar if you wanted to set the height. Okay, you just put R dot height equals to maybe 2. So it will appear here. Alright. So the properties of the object can be accessed, get, or set using the dot operator. So in this example, property width is set equals to 5. So you can just use the dot operator. Alright. So next is defining a constructor. So what is actually a constructor? So a constructor is actually an object is created by invoking a special method. So a constructor is a special method to invoke an object. Okay, so the constructor is a function with similar name to the class name. Alright, so if no constructor is defined, by default MATLAB generates a constructor with no input arguments. So a constructor is actually the way that we wanted to set the value, the properties of your class. Okay, all right, so in order for you to define a constructor, you must put this command inside your methods. Okay, so inside the class it has properties and methods, right? So properties is all about the data of variables, methods is all about the functions. So you must put this function inside your methods, inside your class. All right, so in order for you to define a constructor, you must put function obj. So you must be written as obj. All right, in order for you to define it as a constructor. Okay, so it is actually an object. Function object equals to object name. So the name of your function must be similar to the class name. Okay, in the previous example, the class name is myRectangle, so you must put myRectangle here. All right, and this is the input argument. So input arguments is for basic constructor. Inputs are normally used to set objects properties value. So basically, the input arguments here, it is used for you to set the objects properties. Okay, so let's take a look at some of the example. Alright, so below is an example of defining a user-defined constructor for object myRectangle. Okay, so this is your class definition. So this is your class name myRectangle, and these are the properties. Okay, and here inside the methods, you are initializing a constructor. Okay, so you must put function object, okay, obj equals to myRectangle. So the name must be similar to your class name. Okay, and then the input. So the input, it means that what kind of value that you wanted to set, the width or the height. Okay, so in this example, we wanted to set both w and h, where w equals to object.width and h equals to object.height. Okay, so it is all referring to here width and height. Okay, so this is how you are defining a constructor. Alright, so next, how you wanted to call the constructor and how you wanted to set the value. So below is how an object with user-defined constructor is created at command window. So previously, we only call the function r, okay, we only initiate, or we only creating an object r with myRectangle class. But this time, when we put this command, it will say not enough input arguments, because you already initiating a constructor where before you create an object called an object which contains myRectangle class, you must define the properties of the variable. Okay, so you must call it r equals to myRectangle 3, 2. So this is the width and this is the height. Okay, and then after you give this kind of command, it will create an object r with class myRectangle with properties width equals to 3 and height equals to 2. So it will automatically set the width and height equals to 3 and height equals to 2 because you initiated here, and it is based on your constructor that you have designed earlier. Alright, okay, so next is defining a method. So right now you already know how you wanted to define the properties of your class. Okay, by put it inside the properties part of your class, and then how you wanted to define your properties value by using a constructor. Now we will take a look at methods. Okay, how you wanted to define the methods inside your class. Okay, so the third essential element of a class definition is a set of methods. Okay, so methods are operations that are common or basic to an object. So for example, if you wanted to set a method for the basic operation that can be applied to a rectangle, so based on our example, which is the rectangle example, okay, some of the operation that you can apply, which are you can compute area, you can compute the perimeter, you can scale up or scale down the rectangle shape, or you can rotate the rectangle, and maybe you can also trim the rectangle. So this is some of the basic operation that you can do with your myRectangle class. Alright, so every method is defined through a functions similar to constructor, but the difference is every method name must be different with the class name. Okay, so if you wanted to get this kind of operation inside your class, you can do it by using functions. Okay, so similar to constructors, constructor is also a function, but the name of the function for constructor is the similar name with the class. But if you wanted to use or you wanted to execute this kind of operation, you can create function but with the name which is different from your class, so that you will be able to MATLAB will be able to differentiate either it is a constructor or it is just a function. Alright, so this is an example of defining methods to an object. So okay, so now we can see that this is the class definition. Your class name is myRectangle, and the properties or the variable inside your class is width and height. Okay, and then inside the methods, you initialize a constructor because you wanted to give some input to your width and height. Okay, you wanted to initiate some variables, some value, some data inside the variable width and height. Therefore, you create a constructor. All right. So this one, you are initiating a constructor, and this is the methods. Okay. So methods, if I actually function A, it is like a similar, what we call like a normal function that you did in the previous chapter. Okay. Function A equals to get area, but this time you must put object. Okay. If your function doesn't have any input, you must put object, obj. Okay, so that we can use the dot operator later on in order for us to call the function. All right. So A equals to get area object. So this is the function to calculate the area. We use dot operator here, object dot width dot multiplied by object dot height. Okay. So object is actually when we initialize an object later on, the obj will be replaced by the object name. All right. And then the function obj equals to scale. So we wanted to scale the triangle. So the function name, okay, here get area and scale must be different from the name of the class. All right. So this is how you need to define a method. All right. So next is below is how the methods are applied onto the object myRectangle. Okay. So first, because you already defined a constructor with two inputs, okay, so you must initiate an object A with class myRectangle and with input of 2, 3, because you wanted to set the width into 2, the height into 3. Okay. And then if you wanted to get the area, you initiate the variable called area, and then you put like a dot, what we call a dot operation. Okay. A, which is your object name, dot, what is the name of the function inside your class. Okay. Here the name of the function is get area. Get area in the bracket obj, but obj is already referring to object A here, so you can just use dot operator, A dot get area with a bracket, with an empty bracket. All right. So this is how you can call the function inside your class. All right. You need to use your object A. Okay. So you can get your area. All right. For B equals to, we wanted to scale the rectangle A dot scale. But this time we have a value 2 here because we have an additional input here, scale obj. So for obj we don't have to put anything when we call the function later on, but here you have the input n, so you need to put an input here, a scale with the scale of 2 dot get area. So you can just combine all of the function, okay, in order for you to get the value. All right. So this is one of the advantage for a OOP. You can just combine the functions inside the class that you are defined in an object A. All right. So first, an object A of a class myRectangle is created. Second, area of object A is computed by using methods get area. Third, area of scale versions of object A by 2 is computed first by applying method scale followed by method get area. So what you can see here is that it is easier for you to call the functions. Okay. All right. Next is defining a constant property. So in OOP, you can also define a property which is constant, where you cannot change it at all. Okay. So a constant property is a property whose value cannot be modified after the first assignment. So as usual, this is your class definition called myCircle, and this is the normal properties. Okay, the normal properties is like this. Properties, which next is the properties name, which is radius and n. All right. Next, if you wanted to define a constant property, you must put properties space bracket constant. Okay, and then you put your constant properties here. You must put the properties name and also the value inside the properties, and then you put n. So this is how you can creating a constant property. You type a properties, what we call a syntax, and following by the bracket of constant. All right. So when you call the variables, first you are initializing an object called A with class of myCircle, and then a.pi, this is the answer that you will get because it is constant. Okay, and when you have a time to set the pi, it will become, you cannot set the read only property because it is cannot be modifiable because it is a constant. All right. Okay. Next is all about a private property. So how you wanted to define a private property? So before we proceed on how we wanted to define, what is actually a private property? So private property are properties that should not be visible or modifiable from outside. Alright? So for example, you can also have private methods using an equivalent syntax. Okay, so this is how you can initiate a private property. You need to put properties syntax in bracket access equals to private, and then trim length equals to 1. So you want the trim length property to be private, where other cannot see your properties. Okay, so when you initiate an object R with my rectangle, okay, and it will show you that my rectangle with no properties. Actually, it has one properties here, trim length, but because you are already defined it as a private, MATLAB will not show any properties which has been initialized as private. Okay, but if you are not initialize these properties as private, it will show it here. Okay, trim length equals to 1. Alright, so this is how you can initialize your private property. So the property or the properties that you doesn't want other people to see, or it is not visible from the outside, so they can only see inside the class definition. Alright, okay, next is object array. So next slide shows a class named myRectangle. So for this class there are 4 properties. Okay, so in this class we have 4 properties which their values will be set when an object of this class is created. So in this object, it also has one constant and one private property. So you already learned about constant and private property, right? And a user-defined constructor that accepts width and height value. So in this object, it also has a user-defined constructor that accepts width and height value. So you need to set the height and weight before you initializing the object. Okay, so this constructor also set value for all the 4 properties in one. Okay, so there is one method that can be used to trim the myRectangle object according to the constant and private property value. Okay, so use myRectangle class to create 2 elements vector of myRectangle object that start with certain width and height followed by the trim rectangle. So these questions ask you to use this class, myRectangle class, to create 2 elements vector. So how you wanted to do it? Alright, so this is the class. Okay, so you have a class myRectangle here. So this is the normal properties. You have width, you have height, you have area, and also you have perimeter. Okay, and then you have the properties which is constant. Okay, you set the constant properties here where you cannot change it, which is the trim length. You have already set equals to 1. And then you set another properties here which is a private property, so people cannot see this. Okay, so people will not see the minimum trim when you call or when you initiate the object for this class. Okay, and then this is the methods. So the methods, first you construct you initiate a constructor first, where the initiating of the object for this class will receive 2 data, width and height. Okay, and then from here it will calculate the area and also the perimeter, which is a part of the normal properties. All right, and then you have methods here. So this methods is all about how we wanted to trim the rectangle. Okay, all right, okay, so this is the solution for the example. So if this is all about object array, because we wanted to create an array from the object, so how we wanted to do it? Okay, so a equals to myRectangle 57, because we already initiate a constructor, okay, with 2 inputs, so you must put 2 input here. Okay, and then it will create an object called myRectangle. Okay, and then you will create a rectangle array. So this is an array that you will create equals to a, which is this object. Okay, and at the second column you initialize it as a.trim, which will call the trim function. So it will show you the trimmed value, okay, of the rectangle. Okay, so this is the first row, first column. Okay, so the myRectangle array with properties. So this is a. It will create a rectangle array, with 1x2 myRectangle array with properties with height, area, perimeter, and trim length. Okay, so it will create an array from this syntax, okay, because you initialize it as an array. First you initialize it as an object first, and then you initialize it as an array. Okay, so if you wanted to access the trim value of the rectangle, you can just put rectangle array with the index number 2, because the index number 1 is all about a. Okay, it will give the value of a. Alright, so rectangle array 2 is all about a.trim. Okay, so the answer that you will get is my rectangle with properties with 3, 7, 35, 24, and the trim length is become 1. Alright, okay, next is the case study, the graphic object. So in the graphic object, when plot function is performed, various graphic objects are created to display the graph. So usually when we wanted to plot a function, we need 3 things. We need a figure, we need an axis, we need the line. Okay, so this object has their own properties and methods which can be used to customize plotting. So basically, figures has its own variables and methods, axes also have their own properties and method, and line also has their own properties and methods. So to customize the plotting function, figure, axis, and plot based on the following syntax should be used. Okay, so if you wanted to create a class with to plot the function, you can use this function. Okay, this separate function. This is the function of figure, this is the function of axis, and this is the function of plot. Alright, in order for you to create an object with a class of plotting, okay, you need to combine all of these functions inside your methods in your class. Alright, so this is the function to plot input. So below is a user-defined function to create a plot inside another plot, where properties of the axis and line objects are customized. So all of this figure is all about to plot the function x, y, okay, and x in and y in. This is the first function, and this is the second function which will be plot inside the function xy. Alright, so this is the how signals are plotted using the plot in plot functions. So note that the plot in plot function is also displaying a line indicating the average value of the plotted signals. Okay, so this is x value, which is your is actually your x range, and this is your function y, the first function, and this is the second function. Okay, because you are using the similar x range, so we only initialize only one variable x here. So plot input xy1 and also plot input xy2. So it will create this kind of plot. Alright, so plot inside a plot. So you have what I call a big plot, and you have a smaller plot. So this plot is situated inside the big plot. Okay, so this is how you can plot inside a plot by using graphics object. Alright, so this is the references that you can refer in order for you to study what is OOP and how you want to create an OOP and so on. Okay, so okay class, I think that's all for this class. Okay, so this class indicates the end of our lesson for this subject. Okay, so I hope that you will be able to understand all of the learning session that we already have before. Okay, so after this we will have some of the tutorials or some of the quiz sessions for you. So if you have any questions, you can just ask me in the WhatsApp, or you can just email me, and I will answer your questions accordingly. Okay, so I think that's all for this class for this semester. So I hope that you will be able to get all of the knowledge regarding the scientific programming, and I hope that you will be able to answer your final exams successfully and you will get good result. Okay, so Assalamualaikum warahmatullahi wabarakatuh, and have a very good day.